In January 2025, Western journalists were allowed inside a secret Ukrainian bunker where a group of operators worked through the night without stopping. They were not launching missiles. They were not commanding tanks. They were running what looked more like a control center for a logistics company than a military unit. Targets appeared on screens, drones were assigned, strikes were launched, results were recorded. Then the process started again. This cycle continued hour after hour, day after day. Modern war, at least in one part of Ukraine, had begun to look less like a battlefield and more like a production line. And what was happening inside that bunker may tell us more about the future of war than any tank or fighter jet ever could. The Lazar Group operates less like a traditional military unit and more like a continuous target hunting system that never stops running. Inside their underground control rooms, the work is organized in shifts. So while one team sleeps, another team is already flying missions, and another team is studying maps and video feeds to find new targets. This means the operation does not depend on a single battle or a single offensive because the system is designed to function every hour of every day. Over time, this constant pressure becomes more important than any one battlefield victory because equipment, vehicles, and supply trucks are slowly destroyed one after another. Each person inside the bunker is responsible for a very specific task, and this is what makes the system efficient. Some operators pilot drones, some navigate using maps and coordinates, some analyze reconnaissance footage, some prepare explosives and batteries, and others record the results of each strike. When one drone returns or is lost, another one is already being prepared for the next mission. This kind of organization reduces wasted time and allows the unit to launch many operations in a single night instead of only a few missions per week. The system works like an assembly line, where every step is connected to the next step and the entire process moves forward without stopping. Because of this structure, drone missions are no longer treated as special operations, but as part of a routine process that repeats again and again. Targets are identified, assigned to operators, attacked, confirmed, and then recorded in a database. After that, the system moves on to the next target. This cycle continues continuously, and over weeks and months the total damage becomes very large. This is why some members of the unit compare their model to McDonald's, because the goal is not to produce one perfect result, but to produce consistent results every day using a standardized system. In this drone unit, every operator knows their role, and the mission process follows the same structure every time. This idea represents a major change in how war is conducted, because war is no longer only about battles between armies, but about processes that run continuously in the background. Instead of waiting for a large offensive, drone units can weaken the enemy slowly by destroying vehicles, supply routes, fuel trucks, and artillery systems over a long period of time. This strategy is known as attrition, and it focuses on reducing the enemy's ability to fight rather than capturing territory quickly. Over time, if enough equipment is destroyed and logistics are disrupted, an army becomes weaker even if no major battle is lost. This also means warfare is becoming more about logistics, production, and organization rather than only weapons and soldiers. A unit that can produce drones faster, repair them faster, and deploy them faster will have an advantage over a unit that has better individual soldiers but slower systems. In this kind of environment, efficiency becomes a weapon, because the side that can run its system more efficiently can launch more missions, destroy more equipment, and apply more pressure over time. War therefore becomes a competition between systems rather than just a competition between armies on a battlefield. Drone warfare especially favors organized systems because drones require coordination between intelligence, communication, navigation, and logistics. Without a network to manage batteries, spare parts, explosives, and information about targets, drones become much less effective. This is why the battlefield is slowly shifting away from direct combat and toward networks, production capacity, and information flow. The side that manages information and resources better can control the tempo of the war, even if it does not always control territory on the map. In this sense, modern war is starting to look more like an industrial competition, where production lines, logistics networks, and data systems are just as important as tanks and artillery. The Lasar Group is one example of how a military unit can operate like a production system, turning drone strikes into a continuous process instead of isolated events. Over time, this type of warfare may become more common, because technology allows small teams to cause large amounts of damage if they are organized efficiently. But every system has a designer, and in this case, the architect of this unusual war machine was not a general or a defense contractor. The system that later became known for its efficiency did not begin inside a military academy or a defense ministry, but with a television producer who suddenly found himself living in a country at war. Pavlo Yelizarov was a talk show producer before the invasion, and his life was centered around studios, media production, and television programs rather than weapons or military planning. When Russia launched its full-scale invasion in early 2022, like many civilians in Kyiv, he first followed events through news reports and television broadcasts. But the war quickly moved from something on a screen to something happening outside his home. During the early weeks of the invasion, Yelizarov joined local territorial defense forces, and like many volunteers, he helped organize checkpoints, equipment, and supplies rather than fighting on the front line. What made his situation different was that he had access to personal funds, and he decided to use his own money to support military efforts during those chaotic first months. Reports later suggested that he spent hundreds of thousands of dollars of his personal savings on equipment, supplies, and technical components that could be used for drone development and communication systems. This kind of private funding was unusual in traditional wars, but in Ukraine it became one of the ways new units were created quickly, without waiting for long government procurement processes. One of the key moments came when Yelizarov saw early experiments using drones on the battlefield, and at that time many of these systems were improvised rather than professionally designed military platforms. In one early experiment, an agricultural drone was modified to carry a mortar shell, and the drone simply flew over a target and dropped the munition from above. The idea was simple, but it showed something very important, because a relatively cheap machine could damage or destroy equipment worth far more money. That moment helped demonstrate that drones could become more than reconnaissance tools and could instead become offensive weapons used regularly on the battlefield. After these early experiments, the small group began assembling drones themselves using commercial parts that could be purchased from different countries, especially electronic components, motors, cameras, and batteries. Instead of waiting for large defense companies to design new systems, they built their own devices and modified them depending on battlefield needs. Some drones were designed for reconnaissance, others for carrying explosives, and others for longer-range missions. This type of development looked less like traditional military procurement and more like a workshop environment where engineers and technicians constantly tested new ideas and improved existing designs. Communication became another critical part of the system, and this is where Starlink satellite internet played an important role. With satellite communication, drone operators could maintain connections over long distances and operate in areas where normal communication infrastructure had been damaged or destroyed. Civilian logistics networks also helped supply batteries, spare parts, and electronic components, which meant the drone program depended not only on military supply chains, but also on civilian technology networks and commercial supply routes. This combination of civilian technology and military operations became one of the defining characteristics of Ukraine's drone war. The story of this unit shows a broader pattern in modern conflict, where innovation does not always come from large defense corporations or government laboratories, but often from civilians, engineers, entrepreneurs, and small teams who can adapt quickly and experiment with new ideas. In some ways, this process resembles the early days of technology startups, where small groups work in garages or workshops to build new products before large companies become involved. Some analysts have compared this type of wartime innovation to a Silicon Valley model, where speed, experimentation, and adaptation are more important than formal structure and long planning cycles. Private money, commercial technology, and civilian expertise are therefore becoming increasingly important in modern warfare, and this changes how military innovation develops. Instead of only governments building weapons, individuals and small teams can now design systems, modify equipment, and create new tactics using commercially available technology. This creates a more decentralized environment where innovation can come from many different places rather than from a single central organization. It also means that technology developed for civilian purposes, such as cameras, batteries, navigation systems, and communication networks, can quickly be adapted for military use. This process is sometimes described as technology diffusion, where tools originally created for business or entertainment become tools used in conflict. Commercial drones, satellite communication systems, and consumer electronics have all been adapted for military purposes in this war. This trend suggests that future conflicts may depend not only on traditional weapons like tanks and aircraft, but also on how quickly countries and organizations can adapt commercial technology for military use. But the most unusual part of this unit was not its origin story. It was the people who made the system work. One of the most unusual aspects of the Lasar group is that it was not built like a traditional military unit, but more like a network organization where civilian skills were turned into battlefield capability. In most armies, units are built around soldiers who are trained for combat roles, and the structure follows a strict chain of command where orders move from the top down. In this unit, however, many of the people involved were not career soldiers at all, and instead came from civilian jobs such as administration, engineering, IT support, logistics, finance, and data analysis. Rather than forcing everyone into the same military role, the group used the skills people already had and adapted those skills for warfare tasks. Administrators who once managed offices now helped coordinate supplies, schedules, and equipment distribution. Technicians who previously repaired electronics began repairing drones and communication devices. Analysts who worked with numbers and data started studying reconnaissance footage, identifying targets, and prioritizing which targets were most important. Logistics specialists helped move batteries, spare parts, and explosives to the right locations at the right time. Each person was not trying to become a traditional soldier, but instead became part of a system that allowed the entire unit to operate efficiently. Because of this structure, the unit did not operate as separate drone teams working independently, but as a connected network where information and resources were shared across the entire organization. Drones, ammunition, targets, operators, and intelligence were all coordinated through a central system so that resources could be moved where they were needed most. If one sector had more targets than available drones, drones could be reassigned. If one team needed batteries or spare parts, supplies could be redirected. If new intelligence appeared, the system could quickly adjust priorities. This made the entire operation more flexible and more efficient than isolated teams operating without coordination. This type of organization is sometimes described as network warfare, where success depends on how well information flows through the system rather than how strong individual units are. In this model, data becomes one of the most important weapons on the battlefield, because the side that sees targets first and moves resources faster can strike more often and more effectively. This is very different from older forms of warfare, where battles were decided mainly by the number of soldiers or tanks in a single location. In modern conflict, information speed and coordination can be just as important as firepower. Another important idea behind this system is data-driven warfare, which means decisions are made based on information collected from drones, satellites, reconnaissance teams, and battlefield reports. Instead of commanders relying only on experience or limited reports, decisions can be based on real-time data and updated constantly. This allows targets to be prioritized, resources to be allocated efficiently, and missions to be planned quickly. Over time, This creates a system where operations run continuously, and decisions are made based on information flow rather than slow command chains. Some analysts compare this type of military organization to technology companies, logistics companies, or financial trading floors, where large amounts of information move quickly and decisions must be made in real time. In these environments, success depends on speed, coordination, and information processing rather than physical strength alone. The battlefield in this kind of war is not only a physical space, but also an information network where data, communication, and logistics determine what happens on the ground. This leads to another important idea, which is that modern warfare is starting to look like a platform model, similar to how large technology companies operate. In a platform system, different teams handle different functions, but all teams are connected through a shared network. Some teams collect information, some manage logistics, some operate equipment, and some analyze results. When all these functions are connected, the entire system becomes more powerful than any individual team acting alone. This also shows that military units are slowly becoming more like technology organizations, where engineers, programmers, analysts, and logistics planners play roles that are just as important as frontline fighters. War is no longer only about soldiers and weapons, but also about data flow, communication networks, production capacity, and logistics systems. In modern conflict, information plus logistics plus production often determines success more than individual battles. This transformation suggests that future wars may be decided not only by who has the strongest army, but by who has the best system for managing information, resources, and production. The side that can build the most efficient network will be able to launch more operations, replace equipment faster, and maintain pressure over a longer period of time. Once this kind of system is built, the goal is no longer individual victories. The goal becomes long-term destruction of the enemy's ability to fight. The success of the LASAR group is often measured by the amount of equipment they claim to have destroyed. But the real story is not just about numbers, it is about strategy. Reports connected to the unit describe large numbers of destroyed Russian tanks, armored vehicles, artillery systems, and logistics trucks. And while exact numbers in war are always difficult to verify, the pattern itself is very clear. The drones are not only attacking soldiers at the front line, but are also targeting vehicles, fuel trucks, ammunition carriers, and supply routes behind the front. This means the goal is not only to win battles, but to slowly reduce the enemy's ability to operate over time. This approach is closely connected to what military analysts call a war of attrition, where the objective is to wear down the enemy's equipment, supplies, and manpower over a long period rather than to achieve a fast breakthrough. In maneuver warfare, armies try to move quickly, surround enemy forces, and capture territory in decisive operations. In attrition warfare, the focus is different, because the goal is to destroy vehicles, disrupt supply lines, and reduce the enemy's strength slowly until their army becomes weaker and weaker. Drone warfare fits very well into this strategy, because drones can operate constantly and attack many small targets instead of only large formations. One of the most important targets in modern war is logistics, because modern armies cannot fight without fuel, ammunition, spare parts, and food supplies. Tanks and armored vehicles are powerful, but without fuel trucks and repair vehicles they cannot move or fight for long. Artillery units depend on ammunition deliveries, and if those deliveries are interrupted, artillery becomes useless. By attacking logistics vehicles and supply depots, drones can weaken entire units without directly fighting them on the front line. This is why some analysts say that logistics is the real center of modern warfare, because armies collapse when supply systems fail, even if they still have soldiers and weapons. Another important factor is the cost exchange ratio, which means the cost of destroying a target compared to the cost of the target itself. A relatively cheap drone can destroy equipment worth hundreds of thousands or even millions of dollars, which creates a very unfavorable situation for the side losing expensive equipment. If a drone costing a few $1,000s destroys a tank costing several $1 million, the economic balance of the war begins to change. Over time, if this happens again and again, the side losing expensive equipment may struggle to replace those losses, especially in a long war. This leads to a larger strategic idea, which is that war is not only fought on the battlefield, but also in factories and economies. Modern war is often described as industrial war, where production capacity, supply chains, and economic strength determine who can continue fighting longer. The country that can produce more vehicles, more ammunition, and more drones usually has an advantage in a long conflict. This means war becomes not only army versus army, but economy versus economy and industry versus industry. In a long war, production capacity often becomes more important than individual battlefield victories. Even if one side wins a battle, it may still lose the war if it cannot replace equipment and losses quickly enough. Drone warfare supports an attrition strategy because drones can be produced relatively quickly, modified easily, and deployed in large numbers. Instead of relying only on large and expensive weapon systems, armies can use many smaller systems to apply constant pressure. This constant pressure is one of the key features of drone warfare, because instead of large battles happening occasionally, small attacks happen every day and every night. Over weeks and months, these small attacks destroy vehicles, damage supply lines, and force the enemy to spend more resources on defense and repairs. This creates what some analysts call an equipment loss accumulation strategy, where losses slowly increase over time until the enemy's equipment and logistics systems begin to fail. Logistics disruption is therefore one of the most important goals of drone warfare, because when supply routes become dangerous, trucks move slower, fuel deliveries become irregular, and ammunition arrives late or not at all. When this happens, frontline units cannot operate effectively, and even large armies become less effective if their supply systems are constantly under attack. This shows that drones are not only tactical weapons used in small battles, but also strategic tools that can influence the entire war by targeting logistics and equipment over a long period. But the impact of drones is not only measured in destroyed vehicles or equipment. It is also measured in something less visible but equally important. Drones are no longer support weapons on the battlefield, and in many situations they have become one of the most important weapons in modern war. In earlier conflicts, drones were mainly used for reconnaissance and surveillance, while tanks, artillery, and aircraft were considered the main combat systems. In the Ukraine war, this balance has changed because drones are now used for reconnaissance, attack missions, logistics support, and long-range strikes. This means drones are not just helping other weapons anymore, but are directly shaping how the war is fought and how soldiers move and operate. One of the biggest changes caused by drones is the constant psychological pressure placed on soldiers, because the threat can come from the sky at any time. In previous wars, soldiers were often most afraid of artillery or airstrikes, but those threats were not constant and soldiers could sometimes move or rest with less risk. With drones, the situation is different because a reconnaissance drone can watch a position for hours, and an attack drone can appear suddenly with very little warning. This creates a constant sense of danger, because soldiers must assume they are being watched even when they cannot see anything above them. This environment creates what some analysts call surveillance warfare, where the battlefield is always being observed and movement becomes very dangerous. Vehicles must hide under trees or buildings, soldiers must move slowly and carefully, and supply routes must be changed frequently to avoid detection. Over time, this constant surveillance can cause psychological exhaustion, because soldiers never feel safe and must remain alert all the time. In this kind of environment, even small drones can have a large psychological effect, because fear and stress reduce effectiveness and morale. Drones have also changed the battlefield itself, because the battlefield is no longer limited to the front line. Naval drones have been used to attack ships and ports, which means naval warfare can now be conducted by small unmanned boats instead of large warships. Long-range drones have been used to strike air bases, fuel depots, and industrial facilities far behind the front line. This means the entire country can become part of the battlefield, not just the area where soldiers are fighting. Airports, factories, oil facilities, and logistics centers can all become targets even if they are hundreds of kilometers away from the fighting. The most important message from this war is not only about Ukraine or Russia, but about the future of modern warfare and what NATO and Europe must learn from it. Ukraine is rapidly industrializing drone warfare, building production lines, training operators, and creating new tactics much faster than traditional military systems can adapt, while many European countries are still discussing long-term plans and budgets. War forces innovation faster than bureaucracy, and the battlefield does not wait for committees, paperwork, or political debates. This war is becoming a laboratory of future war, where drone production, data networks, and logistics systems are more important than individual weapons. Future wars will likely be drone wars, industrial wars, and technology wars at the same time, and countries that adapt quickly will survive, while those that move too slowly will fall behind and lose strategic advantage. If you want to understand modern warfare, strategy, and military technology, subscribe to Military Force for more in-depth analysis and real war stories.